Hello everyone and welcome to another video here of the hidden quantum champions on the Polaris School of Quantum YouTube channel. In today's video we are going to take a look at a company called qBraid. Without any further ado, let's jump right into their website and check out what they have to offer in the space of quantum technology. So here we are, and it says the one-stop quantum computing platform. Access the world's most connected quantum startup. Launch qBraid. Connect to QPUs, GPUs, CPUs. No vendor login, no installations. Every leading modality. Get access to 24 plus QPUs and simulators on qBraid Lab. So qBraid or qBraid Lab, which I guess is the offering, the service offering, seems to be a platform in a way that allows you access to these different processing units. So what are these? It's QPU, so quantum processing unit, GPU, which is for graphics processing units. That's the stuff that NVIDIA is selling all the way across all markets. And CPUs, what is, let's say, the central processing units that we know from all of our computers that have been in there for many years. Intel, of course, as one of the very prominent players next to AMD, and of course others that are now in the market. Here's a list of all the providers in one place. So you see the logos are going through. Here's also, I guess, the ones that are spaced inside the quantum area. So we see IBM Quantum Systems, Rigetti, OQC, INQ, Qera, and then AWS. And I think, of course, except of AWS, which is not technically a typical quantum provider, we've also featured all of these already in previous videos of the Quantum Hidden Champion series or the Hidden Quantum Champion series. If you want to see the dedicated videos of those, make sure to check out our playlist, which is hosted on the YouTube channel. You can find it if you go on the channel. There's a playlist with all the videos from the Hidden Quantum Champion series. Okay, let's scroll down a little bit further. It says enterprises, quantum companies, and academics. And then if we click on those, we see different information here. So enterprises. How do enterprises use qBraid? Develop quantum solutions for real-world business use cases. And here I think we see the typical use cases that I've been going through also on other cases, on other occasions of this series with other providers. So we see the financial asset risk modeling, protein-metal interactions. That one I think haven't seen too much before, but I guess that goes into direction of material simulation. Then we have drug discovery optimization, cybersecurity protocols, minimizing jet fuel usage, so in a way a logistics problem, supply chain optimization, financial market predictions, and then there's AI and machine learning plus quantum. Okay, and then of course there's also some more information what these specific ones, for example, do. So we have, for example, here in the drug discovery, utilize quantum algorithms like the variational quantum eigensolver, I guess, to streamline molecular simulations and enhance the drug design process. Then there's this other one here, quantum companies. So how do quantum companies use qBraid? And I guess quantum companies is related to all the startups, but maybe also the companies that are looking into using quantum technology to their traditional business problems now. So it says, connect your QPU, quantum processing unit, or simulator to our network of 23,000 plus quantum developers. So I guess this is related more to the companies that are offering quantum computers already today. So qBraid is a way to give other people access to your quantum system. It says integrate quantum hardware, connect quantum hardware at our managed API service, both on-prem and through the cloud, manage user access, collect device usage metrics, and deploy new software effortlessly. And then the final one, the third one here is in the academic space. It says, how do academics use qBraid, provide your lab direct access to quantum devices with low overhead cost. So effortless quantum research and education using qBraid makes doing research and teaching courses in quantum computing easier, whether using qBraid SDK, so software development kit, for showcasing different quantum Python frameworks, I guess like for example Qiskit, but of course there are also others, or developing a new course to qBraid has a solution which meets the needs of professors, researchers, and students. And then there's here this interface, and you see the different pictures from universities here. Then trusted quantum innovators. You see again some of the labels that we've seen before. There is AWS, Unitary Fund, QEra, IBM, Airbus, Intel, Qcontrol, and NVIDIA. And down here, there's like 3 different points mentioned. AI for quantum, use inline completion code, code generation, and ChatGPT enhanced search in all qBraid Lab. qBraid Lab is the service that we saw before. Unified login, access Amazon Bracket, Azure Quantum, and more, all with one qBraid login. So they have some type of single sign-on, I guess, mechanism to access those hyperscale providers that now also provide quantum access. Azure Quantum for Microsoft, and then Amazon Bracket for the AWS side of things. And then launch on qBraid. Clone your public GitHub repositories with a single click, making file additions to qBraid effortless. Here we see, I guess, what the system looks like. So you have qBraid Lab as the base foundation. On top of that sits a Jupyter instance. So Jupyter Lab is a interface to do Python coding, for example, on a cluster computer or whatever. And then here, I guess, we see the different hardware interfaces. So we see Rigetti, there's NVIDIA over here. And then also some applications, so finance, machine learning, life sciences, manufacturing, logistics, and security, and some company names sitting on top, like Circ, which is, I think, a programming interface. There's Intel, Qiskit, which again is a programming interface, AWS as the Amazon service provider, PyTorch, which is an interface for machine learning in Python, and then Microsoft as well. It says, build your heart out, skip the hassle of cloud and authentication setup, and use our automated platform, quantum computing tutorials, documentation, and AI copilots to start building tomorrow's quantum computing applications today. Build your first quantum algorithm with ease using qBraid Lab Cloud IDE. And then there's also some link here to explore on GitHub. So there are notebooks, there's CLI, there's OmniSearch, code snippets, quantum devices, and qBraid documents. There's qBraid runtime, lab environment manager, access to GPUs, and then also here it says quantum jobs. Track your quantum jobs effortlessly with qBraid, monitor progress and results in real time, all in one place. So that's very interesting. That's, I think, an offering that we haven't had on the series so far. So it's basically like a quantum native cloud scaler or cloud software interface, cloud service, which allows easy access, I guess, to different programming languages, and then also different different quantum devices, together with documentation and instrumentation to make it easier to actually work with those systems. I think that one here also looks interesting. So the qBraid runtime framework simplifies quantum computing by integrating sessions, providers, devices, jobs, and results into a cohesive workflow that generates tailored targeted profiles, program specifications, and compilation schemes for each provider. And I think that's important to mention, because that's something which also plays a big role. For example, when you look into things like think about using a quantum computer together in a loop with a classical computer to do some type of machine learning approach. So you want to make use of the quantum computer to get access to the Hilbert space and do some, let's say, machine learning on the quantum computer, but then still you need also classical computer to tune your parameters, for example, in the training phase. And for that, you need to somehow loop up, let's say, your quantum system and your classical system in a way that you can run both of these efficiently in a queue, right? So if you, for example, think about you get access to, I don't know, think about you have the IBM system, for example, in the IBM cloud, you can put a command in the queue, and then it will sit in the queue, and then it will move closer and closer and closer to execution. Then you execute it. You run the optimization loop on the classical computer. You send back again the next data set. And now again, it has to sit in the queue and wait and wait and wait until it's executed. So it takes forever to actually do this type of tuning if you rely on this queue. So if I guess you have a runtime like this one here, you can combine those things and make sure that they can actually be executed fastly and cohesively. There's also some lab environment manager here, so it talks about the different programming languages like Python, Qiskit, which is more, let's say, which is an IBM originated open source language for programming quantum. Julia, which comes from the high performance compute world. C++, which is, let's say, a very basic and efficient programming language. And then there's Q#, which I think is the C# analog from Microsoft. So the Microsoft quantum programming language. Okay, and then finally down here it says how to get started in quantum qBraid style. Learn quantum computing with qBook and qubes. Join our White House Q12 initiative course to master quantum computing, covering the basics of quantum computing. So again, we are also here in the education space. So I find it very good that qBraid is also, let's say, working on this, helping people to learn about this technology. I find this is and I might repeat myself here, I find this is a very important thing that everyone can kind of learn, easy access and understand about what these quantum technologies are, not only computing, but also sensing and communication, so that everyone can make up their own mind and make up their own understanding about those technologies, where they are, and how to make use of them, possibly, or maybe even not. Then it says, write your first quantum program with lab. Launch qBraid Lab from account.qbraid.com to start coding with managed quantum environments and direct quantum hardware access. Then use qBraid CLI and qBraid SDK locally. Seamlessly integrate quantum computing tools, manage jobs, and access quantum hardware directly from your own system. So that's basically where you then install it on, I don't know, for example, your Mac, and it will access via the API interface, whereas here you probably use it from your computer, from some web browser interface. And then finally here it says run hybrid algorithms with the qBraid runtime, execute hybrid algorithms effortlessly, and bridge classical and quantum computing for optimal performance. Then, as per usual, down here we have some way to subscribe, I think, to a newsletter. There's some social media link down here and the usual links. With that, let's quickly go up again and check out the product, solutions, resources, and then also a little bit about the company. So products, let's quickly check out the overview because we don't want to make it too long. I think we've also learned quite a bit already on, let's say, the basic idea. It says shape your quantum future on qBraid subscription. One qBraid subscription unlocks many additional platform features, while credits are used for runtime on QPUs, GPUs and CPUs. So there are different plans, which I guess give you different number of credits, which you can then use for different types of compute units, which I think is also good, because if you, for example, realize down the line that you only need QPUs, you can still reuse those credits for this specific compute units. And then, of course, if you realize you need more quantum, maybe later on you can still switch, so you get a lot of optionality. Then it says access to 24 plus quantum devices. That's what we've talked about before. Here you see some of the labels, so like Qiskit, I think this Xanadu, Q control, and so on. Through 4 different services, all with one account. So there's the qBraid lab, code quantum smoother, skip the hassle of software installation, and code on cloud-based IDE with 24 plus quantum devices available. Take advantage of our environment manager to install and deploy quantum software with a few clicks on lab. So this is what we see here. Then there's qBraid runtime, utilize quantum smarter, write once and target all gate-based quantum devices on the most connected quantum software in the world. Take your quantum computing deployments to the next level with qBraid SDK's runtime service. So it looks like you basically write the code once and then you can use the qBraid one runtime to decide, for example, which QPU you want to run on. That way you can always, go for the one that is handling the tasks that you are having, the algorithmic tasks that you are having most price efficiently, for example. And you can easily switch, I guess, between those using this. Then there's qBraid R&D, deploy quantum first, understand how quantum computing can help your organization accelerate and find value, work with our researchers to harness cutting-edge algorithms with your existing pipelines. There's qBraid qBook. This is, I think, the education material that we saw before. Learn quantum faster. Quantum computing may still be nascent, but your expertise doesn't have to be. Gain exponential advantage in your ability to learn quantum computing with our award-winning platform. So I will check that out after the video because I'm very excited to see the award-winning platform. And I think that's it for the products. Then quickly also check out on the solution side of things. So here it says quantum starts here with this very fancy animation here. Okay. It says discover tailored solutions designed to accelerate your business, streamline workflows, and solve complex challenges no matter your industry. Contact us. Quantum computing companies deliver robust access, enterprise integrations, and a premium branded user experience for your customers, developers. So this is if you are a quantum company. Then if you are a developer, accelerate quantum development with qBraid labs as well as integration with VS Code, Cursor, and Windsurf. These are programming interfaces, programming environments. If you're academia, what qBraid offers you is equip students and educators with tools to teach and learn in the quantum era, minus the infrastructure hassles. And then if you are an enterprise, what they can offer you is transform your operations with cutting-edge quantum applications from finance to logistics to life sciences. In every case, there's some more information if you click on that. Quickly also looking here at the resources. So we see documents, the software development kit, there's also a GitHub link, there's a blog, and there's the about page. Let's hop right to the about page. Here it says democratizing quantum computing. So also again, there's a certain alignment here. We democratize the education around quantum technology. They democratize the access or the quantum computing access, I guess. qBraid is the world's most connected quantum software platform. It says, our mission, we democratize quantum computing, driving innovation across industries. Our platform and our research enables users to tackle challenges beyond the reach of traditional computing. Funded in 2020, they have over 23,000 users in over 120 countries, over 200 universities using their tools, over 4,000 citations, and 24 quantum devices currently accessible. There's also this video here and a list of the partners. So you see Microsoft, IBM, Google, AWS, Rigetti, Quera, INQ, OQC, Xanadu, Intel, Chicago Quantum Exchange. So they're also a Chicago-based company in the US. Chicago is a very interesting place nowadays for quantum companies in the US. Then we see NVIDIA, the Quantum Algorithms Institute, Argonne National Laboratory, QEDC, Quantum Systems Accelerator, Duality, Fermilab, the University of Chicago, and MIT Delta V. Then also a list of the investors down here and some prizes that they have won, as well as some overview of the team. Meet the team. We are scientists, developers, and innovators. Our team of specialists in quantum physics, quantum science, and engineering are all driven by a shared passion of advancing quantum technology. And here we see from various different universities, both I think within the US and probably also outside the US. Yes, also outside the US. So an international team of people with, I guess, different backgrounds working on this business idea here, or on this business. With that, I think we are already at the end of today's video. That was a, let's say, quicker one than some of the recent ones, which were pretty long. I find it a very interesting concept that you have, let's say, a platform sitting on top of also other platforms, making it easy for you to switch between, because I also think that different quantum computers at this stage, at the NISQ era of quantum computing, have different advantages. So think about, let's say, fidelities, about qubit scaling, about the speed of operation. So different platforms have very different benchmarks on these different aspects. Also, for example, qubit connectivity. And with this, it also plays an important role as to which platform caters best to your algorithm. So if you, for example, need to have a very high connectivity, you might not want to use a system where you can only maximally create a entanglement across 5 qubits, right? Because you might need more, because that might be relevant for your algorithm. Or if you want to do a lot of computations, you might not want to use a system where one computation is taking you a couple of seconds, because every gate takes a couple of milliseconds. So there are different requirements and different systems, and I find it very interesting that this platform is basically catering to all of them, because when you start your journey into the world of quantum and you try to figure out, okay, what are the use cases that I want to look into, what are the algorithms that I want to look into, you of course don't know at the very beginning what are these specific requirements that you have. And I think there it is really helpful to have this interface here, which offers you interface to various different quantum systems and also various different programming languages. On the other hand, I also find it very good for the quantum companies, for the quantum compute companies, because they can actually have a greater user base experimenting with their systems, and thereby also learning more about what users are actually intending to do with their systems, what users, what maybe also problems with the systems when you run them on a long extended period of time. And you can accumulate, I guess, much more statistics on usage of your system. So I think there are various different interesting aspects. With that, I want to now move on to check out the educational offer and also close today's video. If you like this video, as always, please make sure to give it a thumbs up. Also, subscribe to this channel if you want to support us on this mission to democratize the quantum education, because it really helps us to get more reach within this YouTube platform. And with that, I thank you for your attention in today's video. As always, make sure to stay hydrated, and then see you in the next video. Bye bye.